Okay. All right. Good evening, everyone. Welcome to tonight's Learn and Lead session from Asian Women Advancing AI. I'm Uvika Sharma, and I know a lot of you. I'm super excited to be hosting this session alongside my wonderful co-host, Padmini Soni. So thank you so much for spending the evening with us. Um, we are going to be having an amazing speaker who's going to be spending some time with us. So I'll just quickly cover how the flow of the evening is going to progress. Padmini is going to introduce our fabulous speaker shortly, and then we'll have about 30 to 40 minutes of presentation, followed by an open Q&A. Feel free to drop your questions in the chat anytime. And just a quick reminder to please stay on mute unless you are speaking during the Q&A. And with that, I'll hand it over to Padmini to introduce our amazing speaker.
Thanks, Uvika. Hey, everyone. Thank you for being here today. So let me introduce our amazing speaker. Priyanka is an award-winning AI IoT specialist at AWAAI. She was named Channel Asia Women in Technology 2023 winner and recognized as a top woman voice in AI. A three-time Microsoft AI MVP, she brings several years of experience in AI strategy, architecture, and innovation across Southeast Asia. She has led pioneering work in generative AI, including the first enterprise Gen AI deployment in the region using tools like Azure OpenAI, LangChain, and vector databases. Her solutions span industries from government to finance and emphasize ethical AI, sustainability, and intelligent decision making. Priyanka is also a passionate speaker, mentor, and advocate for empowering others through AI. Today, she's going to speak about AI factory platforms, AI infrastructure as a service. Can't wait to hear more from Priyanka on that. So please join me in welcoming Priyanka Shah. And over to you, Priyanka.
Hey guys, thank you so much. And Padmini, Uvika, thank you for having me and for the generous introduction. So without much ado, let's dive in, right? So what is AI factory? And again, just one disclaimer. People usually ask me, is it like a product? Is it like a offering, available on Azure platform or Foundry platform? Many people confuse it with the Foundry, Azure Foundry platform. So AI factory is a moniker which we have given to the platform which we have built, but yes, it is built on top of Azure ecosystem, Azure platform services. The only thing is, and yes, it is available as a service, right? But then it's not monetized or licensed. The GitHub repository for this is open, and I will be sharing out the link with you people to be able to extend it and deploy it at your own organization, right? So at our client side and internally, when we chose to build this platform, we named it as AI Factory because then we are able to generate and deploy Gen AI applications at scale, just like a factory platform, right? So which is why the naming convention, but otherwise, it's not like a licensed product or something. So already, been introduced. So you can connect with me on my LinkedIn handle, and also, I write regular blogs on medium.com under the name of AI Geek. Okay, so right now, what is the need for us to be talking about infrastructure as a service for Gen AI applications, right? So if you look at the LLM tool chain, which starts with your LLMs and then your memory, orchestration, and then evaluation and monitor, experiment, improve. These are the observability frameworks, which essentially are towards the tail end of your Gen AI deployments, right? So provided your POCs or MVPs or MLPs, they go into production, is when you will have your evaluation and experimentation metrics and improvement coming in, right? Mostly your organization, let me have the pointer. Yeah, mostly all of the organizations which are experimenting with Gen AI are usually at this three steps. But when you are moving your solution into production, then you come across this evaluation monitoring kind of cycles, right? So if we look at the common pains which AI teams face in LLM app development and also, productionalization. So at every stage, you will have some or the other roadblock. And especially if you look at this evaluate, iterate, production, and improve, right? Right now we don't know the effects of making a change. For example, imagine, when we deployed a solution back in the day with OpenAI GPT-3, it was not even 3.5 or your advanced GPT-4 models. It was GPT-3 Da Vinci instruct model. So what happens if a new version comes in? Do I just swap out the API? Is that it, or do I need to do something more? So I don't know the effects of making a change, right? No proactive protection against, again, all those your guardrails and gates. I don't know what kind of queries are going to come in from my end users, and how do I collect the telemetry, and how do I actually evaluate the consumption and what is going inside of the platform, and then focus on improvements, right? So these things are somewhat of right now pain points, and again a black box. Like, I don't know what goes into the call, what comes back, and how do I decide that, hey, it's time for me to have more OpenAI instances. It's time for me to deploy more AI service instances. Apart from your high availability and disaster recovery requirements, I just may want to proactively scale and have different kind of a different number of instances across different environments as well. Like my dev environments could have different instance requirements, my production environment could have different requirements, and so on and so forth. So these are some of the, real on ground pain points and feedbacks which we've gotten from clients where we've deployed GenAI applications and moved them from POC into like a operational production mode. Okay. So common thing once you move from deployment to production is how many Azure OpenAI instances should I have, or how many Azure LLMs should I be deploying? I want to monitor my quota usage. Okay. And again, people who are living in my side of the world, the APAC side of the world, some of the models are not available locally. What do I mean by that is, if you look at the Azure GPT-4o model or the newer and the reasoning models, right? Those models are not available in my local Australia East region. Okay. So what that means is, when I'm putting a system into production, especially in government, federal departments, or even insurance, healthcare. So there is this requirement of data residency, which means my data should not leave my geographical region. But if your instances are not available locally in Australia region, we need to have something which is called as provision throughput. So I need to proactively purchase some compute from Azure and then deploy it locally in my region, so that my data is processed inside of the region. So when you say PayG, these are your pay as you go instances, and PTU are your provisioned reserved throughput instances, right? Which you reserve in advance, and of course they have a guaranteed throughput, and it's not like a shared compute. Okay. Unlike your pay as you go models. So how do I prioritize? And it's expensive, right? So which means, how do I prioritize that which application should be given PTU? And of course, PTU should also be prioritized only for production workloads. How do I round robin between multiple AOAI servers? How do I put some rate limiting constraints on my lower environments? Okay. How do I charge back my different departments for their usage of the quota, right? So maybe I have two Azure OpenAI instances, and I have like 15 departments in my organization consuming those instances. And at the end of the month, I want to allocate a proportionate chargeback to each department. And then how do I do that? So for all of these things, which is why we introduced, this AI factory platform. Okay. So what does it do? It is a scalable, secure environment, right? It accelerates the development time. How does it accelerate the development? Okay, and I'll shortly show you the architecture. But I think all of you know that this is a very common scenario with your enterprise or your clients. It's that everyone is at this cusp of AI discovery and POC and innovation. So even inside of your client, so let's say my client is a health insurance client, Inside of that, they might have a lot of departments. So there is the finance department, the legal department, the IT department, the IT support, help desk, service management department. Each of them is doing their own Gen AI POCs. So the IT department is doing some scalability throughput related things. The insurance department is doing some claim processing POCs. And each of those, they will go back to your infra and security and your cloud ops guys, and they'll ask them to spin up a sandbox environment, right? And then that sandbox environment is like the infra and the cloud tech ops or the network ops team. They will ask you about your POC, they will approve something, and then they will provision a sandbox, and then that process has to be repeated for all the various departments with some exceptions. Like some might require exception for using, models which are not available locally, citing that, hey, I'm just working on public data. Some might have very confidential client data which they are working with, so they might have additional heightened security requirements. And then it becomes a pain point, right? Like you are wasting that much of your cloud infra, SecOps, IT time just provisioning those environments, putting those policies in place, and then you will repeat that cycle when you want to move from the POC to production. Okay. So if you look at the sorry, so if you look at the architecture, right? So current architecture is something what we have on the left hand side, where each of the departments will have their own repeated set of services. The security and the cloud network ops and all other teams will come in. They will try putting policies around each of your individual deployments, and then it all becomes a mess. Like I don't have any control on my consumption of Azure AI services, my other AI services. Data is siloed. You don't have any interoperability because every department has their own singular sandbox or subscriptions, and nobody's talking to one another. And this happened in real. Okay. So one of the departments was doing a claims insurance POC, and claims are like they were processing around 300,000 claims and in that POC. And it so happened that they racked up a consumption of around 100,000 USD in 5 days, because that was the kind of data they were pumping in, and that was the kind of documents they were processing and ingesting into the AI search. So this has happened for real. Like the reserved compute was run out. So compute which was supposed to be for the entire vertical for probably a month or so was consumed by one POC within 3 days, 100,000 USD. Imagine that, and that is just the Azure AI and AI search consumption cost we are talking about. So this kind of unmonitored usage and unaccounted usage is where we want to then bring in some semblance of a governance and a centralized control tower, right? So these are your applications now. So applications will just have their data and their AI search, like their indexes based on how confidential the data is. Otherwise, the AI search also can be centralized. But applications will just provide with the data and the search. That's it. Then comes the factory platform. So all of the applications will get access to the Azure services, which consist of Azure OpenAI as well as other Azure services, language service, speech to text, video analytics, document intelligence, all of that via your API management, right? So APIM is, so if you look at the high level architecture, APIM is the gatekeeper. All applications will access your AI services via the APIM. Now, APIM will, do some logging in the event hub. So what it will log is your request time, your authentication, the kind of APIs you are going to invoke, number of pages, character counts, completion tokens, prompt tokens, whatever the amount of, logging, granularity logging you want to do, you will put that in an event hub. The event hub then triggers custom Azure function. So as you can see, the event hub, it triggers a custom Azure function. That custom Azure function then can, do a lot of things. So it can calculate the number of pages you were using for document intelligence or OCR. It will log your prompt tokens. It will log the API which you're calling. Is it a GPT 4.5, is it a GPT 3.5, is it PTU, is it pay as you go? It will log all of that in the telemetry, so application insights. And from the application insights, then you can, actually run queries and you can get all of these usage statistics. And then here is all your services which you're having, right? So your OpenAI service, speech to text service, language service. So this is deployed in one single subscription. This subscription access is gated by APIM and then, event hub functions. And then these are your consumer applications. So consumer applications just need to get access to the APIM and that's it. What happens downstream, how, we are controlling the failover. So if, how we are giving the different APIs, whether we are giving them a GPT-4 or 3.5 or a 4.0 mini or a PTU or a PG, all that is taken care inside of the logic, which is APIM Event Hub Azure Functions. And then, we are we are then invoking the desired APIs, giving back the result. So, and this is a repeatable Terraform template. So this everything is now templatized, kept as a Terraform template. It can be easily deployed to higher environments. Any new POC comes, they or any new requirement, innovation, MLP, MVP requirement comes, they come to us, the factory team, what we term it as, and they are like, hey, guys, we want now access to AI search, document intelligence, OCR model, pre-built layout, language service, sentiment analysis models, and we just give them a subscription key. And then, we tell them the APIs to call, right, according to their requirements, and that's it. So they only know that they are going to hit the endpoints which you give them, and then all the security governance policies, everything is pre-built in the environment. So just imagine the amount of time you are saving. So some real-time statistics. Earlier we used to take like 2 to 3 weeks just to provide all those provision, all those guardrails and platform requirements before a department to get started with the POC. Now this architecture itself has been vetted by the governance forums, the architecture review forums, and the security team and everything. So this is like a properly secure with all the guardrails in place environment, and which is why any new POC just needs to get approval that okay, you're approved, your use case is approved, now go use the platform, and within a matter of 2 days they are able to get up and running with their requirements. So imagine the amount of time savings, and sometimes just half a day. What we need to do is give them a key, key, and that's okay. So if you look at the logical, right, this is the end users, okay, and the consumer application. So we are then just they are just going to hit the APIM, and all the magic then happens inside of the APIM and the APIM policies which we are putting in place, right? And so this is a real kind of what is it, like a real accelerator platform. And as I said, quite easy to get up and running with new use cases, and that is what we are calling deploying Gen AI. So every time a new AI service comes up, so now today, tomorrow there is a content understanding service which has been announced, which was in preview, but now it is GA. It's just a matter of adding one another box here. So another Terraform line of a couple of lines of Terraform code, and that's it. Because it is the environment itself has already undergone security reviews, and everything is provisioned with the correct VNets and firewalls and correct security policies, and again private endpoints, managed identities. So if at all a new thing comes, I just need a couple of lines of Terraform code and then deploy it in my test and UAT environments, and that's it. So again, if something new comes, I don't have to repeat my architecture governance process. And typically in banks and insurance organizations, you can imagine how cumbersome and onerous these are. Again, now a few things, right? What we are also doing is, so there are so this was about the architecture, but inside the complex is what we are handling, right? So as I said, we are we can have applications with different priorities, and they should be able to access endpoints accordingly, right? So like a cat application with a high throughput and immediate response time should be able to hit a PTO endpoint, right? But what happens if your OpenAI instances are overwhelmed? Can happen. Like in the dev environment, especially, I have few instances available for applications to invoke, and they can get easily overwhelmed. So then instead of blocking my applications and giving them a 5 to 9 kind of an error, okay, which can be a rate limit error, or which can be a service busy indicator error, I am going to fail over gracefully to other available endpoints. So even in the case of my provision throughput endpoint, which is my reserved compute endpoint, if my application hits that endpoint, right, okay, but then it is busy, as you can see that this is temporarily throttled, I am going to gracefully fail over to the next available endpoint. So the application might experience latency, sure, because it's now a pagey and a lower quality endpoint, but then at least it's not disrupted. It's not going to give you disruption errors, right? So this is how we are load balancing as well between different types of instances and between different number of instances. And there are a lot of such algorithms and decisions to be made internally. So there is something which is called as exponential backoff with retry. So as you can see, there are PTUs and there are OpenAI TPMs, token per minute, right? So instead of if some of your endpoints do get a 5 to 9 or a rate limit error or a service unavailable or a busy error, then what we do is for certain point of time we put a stop, right? Okay, so like instead of retrying immediately, we put a stop, and then what we call it as exponential back off with retry. So maybe if you and this works beautifully in a case where you have concurrent users, hundreds of thousands of concurrent users accessing your enterprise workload. So imagine like a call center chat application which is quite chatty, quite back and forth, and number of concurrent users. So some users might experience a kind of slowness or latency because they are now paused for a few seconds before retrying to hit the endpoint, but other users are then serviced. Okay, so it's just like, hey, wait, I'm busy, and then I will automatically retry after a fixed interval rather than continuously monitoring and overwhelming all the endpoints and getting a busy error constantly. So some of our applications might also be able to experiment with exponential backoff retry if they don't want to really have a lot of instances provisioned for these cases of busy peak times or busy interactions. Okay, then also when we have, for example, all applications have equal amount of criticality, then what do we do? Okay, so then we have to implement something which is called as weight based routing. I will come to this weight based routing part, but let's look at the demo first, because this weight based routing is a bit advanced concept, and I would first like for us to see the existing demo of the AI factory, right? The APM and the logging auditing which happens, and then we come back to the weight based routing. Okay, so let me jump to my demo. Sorry. Okay, so look at this now. This is my factory, what I can say deployment, and again, as I said, it's a Terraform. So all of these services, these application insights and everything is deployed via Terraform, and even the and this is the Azure function which has the custom logic which needs to be implemented. So let me first show you my APIM and how it looks like. Okay, so this is my API management service. Okay, let's look at API endpoints, and I have some test scripts to simulate calls, right, to my service, to my OpenAI service. So this is my API. Sorry, it's a bit slow. Yeah, okay. So this is the, I'm calling the Azure OpenAI deployment. I have different deployments. I have, 3.5. I have 4. I have a 4.0 mini. but then all of them is gated via one API endpoint. So my end applications are going to see just this one endpoint. Okay. And so if you go to the test here, this is what my my applications are going to see. Sorry. Yeah. So this is the endpoint my applications are going to see. That's it. Okay. If you see the request, so HTTP request, something, this is what I'm going to see. Internally, what is happening, how I am load balancing, what are the number of instances, everything is controlled in this particular snippet. Okay. So you see, I'm setting the backend. Sorry. So I'm setting the backend, and then I'm authenticating. So the applications, consuming applications, I'll be giving them API tokens or subscription keys, and using those subscription key, I'm going to then authenticate them. Okay, and then I am also able to write some small amount of code inside of the Azure APIM policies. So I am then what I'm doing is I'm once the request is successful, I'm logging it into the event hub. So this is the event hub logger policy. I'm logging, what am I logging? I'm logging the date time. I'm logging the operation, which is, it's a chat completion. It's it's a text completion. It's a document intelligence, OCR, whatever the kind of operation, subscription key, the request and the response body. So these all things I'm logging in. Okay. Again, you can have multiple backends. As I said, it's a GPT-3, it's a GPT-4, and then there will be also policies for the graceful failover. Like when the GPT-4 endpoint gives me a 529 or a busy error or a any other 500 error, I'm going to gracefully turn back the application to the other endpoint. So all of this is absolutely not known to the consuming applications are just like I'm invoking one API and that's all. All of this magic happening in the backend, it's a black box. Okay. So what happens now? I have logged. Once I have logged this inside of the event hub, automatically the event hub, it triggers my Azure function. Okay. What the Azure function then does is the Azure function then calculates. So for example, I want to calculate my OpenAI token function, right, in a streaming mode. So in a streaming mode, for the calculation of tokens, I need to have something which is called as a tick token library. So now the Azure function has custom code where it uses those tick token and other libraries to be able to compute the token usage, and it logs it to the application insights. So now if I go to the application insights, it logs it inside of a table which is called as custom events table. Okay. So if I go to logs, right, in the monitoring, and in I will be able to, yeah, when I go to the logs, I will be able to then query my custom events uh, uh, table, and then I'll be able to then actually see the consumption. Okay, so let me show you how it looks like. So let's say, for example, this is the query which I have ready. Let us try custom, and let us try from March to today. Apply. Yeah, you can see. So these are the different applications. These are the subscription keys of those applications, right? And then this is how it will be logged. This was the number of prompt tokens this particular application used till date, right? So from the time range which I have given. So these are the completion tokens. These are the total tokens. And same way, if there is another application with a subscription key starting with 997, right? So internally, I tell you, right, this application is pointing to the GPT-4 API endpoint. This application is pointing to the GPT 3.5 endpoint. But then, these are the keys, subscription keys. Internally, these subscription keys might point to different products or different enterprises. So I have not shown the names, of course, but then this is how you'll be able to get, right? And then you can compute. So let's say if your consumption was 1,000 USD, you already know that, hey, this application has consumed XYZ tokens. So this is the usage. of OpenAI for this particular department, and that's how I'm going to charge back. Okay, and we can do it for real time. So I'm simulating certain, calls here. So this is a test completions endpoint I'm going to invoke, and let us invoke again. So this is like, uh, hypothetically simulating an API call, and then we go back again, okay, and then we run the query again. It definitely takes some time to be able to log, right? But then if I do the last 30 minutes, okay, so it is still logging, right? So if I do that, it is still logging. The Azure function is calculating and logging, and it takes some time for the telemetry to reflect that, right? But then in the last 30 minutes, it will actually show me, it will log and it will show me the usage. So I logged in 2 function calls right now. Sorry, I logged in, 2 API calls right now. So it should be uh, showing that telemetry. But maybe it is, taking a bit of time for the telemetry to reflect. But then you have this KQL mode, and you have the SQL mode, and this is the query which I'm using. So custom events is the table where the Azure function actually logs all the telemetry, and from there I am then running this query to be able to show you the actual log of what was going on. Okay, so if I do this, and if I run again time range custom, oh yeah, now you see the tokens increased, right? There were earlier some 400 and something tokens, and now you can see after the 2 calls which I made, the tokens have increased. So it is showing you the, and again, earlier we saw 2 applications, right? So now I have changed the time range, and then you can now see that the 2 calls which I have made, it has logged the token count. And again, as I said, right, this is just a simple token calculation, but you can log in as much as you want to, as detailed as you want. Yeah. Okay. Moving back to our, you know, hey, were you able to see my demo or no? Sorry.
Yeah, we were able to see it.
Able to see, right? Okay, no, because my my PPT was still in screen sharing mode. Anyways, okay. So now we come back to the peak load handling, right? With load distribution patterns. So see, the thing is here, in the sample demo which I showed you, there were just 2 endpoints. But in realistic real-time applications, real-world application, you will see that there's different endpoints available in different geographical areas. So there's 3.5, there's 4 omni, there's turbo, there's a 412K, 430, sorry, 48K, 432K, those kind of things. And then again, my applications might have again variable priorities as well. So what if 2 categories at once are invoking my APIM endpoint? So this is the APIM endpoint. Now in the APIM, I will need to have some kind of a weight-based routing where I assign a probability for each endpoint to be picked up, right? So higher probability for PTUs and high reasoning ability models to be picked up, and some lower probability for some other endpoints to be picked up. But then I will have some probability always for any endpoint to be picked up. Okay, so which means my application APIs will never be overwhelmed, because as soon as you see that the most probable endpoints are already picked up and busy, you will automatically route to the next probabilistic or the next weighted endpoint available. So which means at any given point of time, you're not ignoring any API, and that is why you never find something, service disruption at all. But this is a trial and error method, like how you assign the weights to those endpoints, and what are the, um, probabilistic features you're going to assign to each of the endpoints, right? So this is the calculation algorithm which I was telling you, right? So this is the application. It will call my APIM. The APIM will log, the things which I showed you in the Azure policy to the event hub. Event hub triggers a function. Function will, log everything into the telemetry, And meanwhile, the APIM is, accessing the OpenAI instances giving back the response, and the response also, whatever we are getting from the response also is logged to the event hub called Azure function. Azure function extracts whatever it wants from both the request and response. There is authentication also going on, so the APIM also takes care of authentication, and that is how your entire end-to-end ecosystem is then supported. Yeah, and then what services our current deployment supports. So we support OpenAI, any flavor of OpenAI services. We support NLP, natural language services, speech to text, computer vision, document intelligence, Foundry, right? And then we also have an onboarding process for applications in place. Like when you have to come and use our AI Factory platform, and before we give you the APIM subscription key to be able to access our APIM, then we have these things in place, right? Like we have business sponsors, product owners, tech leads. Then we have this use case alignment with AI Factory capabilities. For example, if someone wants to use Databricks, well, that is not currently supported, then we might add it to our product backlog and provide it as a feature later on, right? Then what are the models you need? So right now we have like 4.5, 4.0, 4V, and O1 and 4.0 mini. But what if you want a 5.3 model? Or what you want like Llama 3 model? So these kind of things also then we need to check if feasible for us to provision in our environment, and then does it have to run through any security process, and so on and so forth. Yeah. So with that, I come to the end of my presentation. Any questions?
I believe we have a question. Dipti, you had a question. Did you want to ask that?
Yes, I have written the question. So my question is why we are counting tokens?
For chargeback, right? So as I said, for example, in a situation, so let me go back to my screen. Tokens are there for chargeback calculation. So if you look at, if you look at this here, okay, put it in. If you look at this here, these are my applications. Okay, so imagine my health insurance client has 3 different departments who are experimenting with GenAI. At the end, it is cost to the company, no? So they have a subscription where my departments are experimenting, and each department has their own budget. So legal HR department has their own budget, the legal department has their own budget, and let's say the back office IT services has their own budget. Now this is the infrastructure team who's managing Azure subscription. Okay, so let's say if they are asked a question that, hey guys, our Azure consumption is through the roof, why? Okay, so what metrics do they have? Because if you see here, each department has their own sandbox. There is no accountability, there is no visibility into who is using how much. So if uh, uh, all my tokens were consumed, so right, every deployment will have a token consumption. So sometimes applications come and say, hey guys, I'm getting time of error like again and again. Why? Because of course I have put in a rate limit that in one day you cannot exceed more than 1,000 tokens, a TPM limit, right? Or this is your quota for the hour, that kind of a thing. So all of these policies need to be put in place. Again, as I said, at the end of the month, someone comes and asks that, hey, all my reserve compute was exhausted. How come it was exhausted? So without having this logging, who is using how much, how are you going to charge back that to the department? How can I go back and say that, hey, all my Azure quota was consumed by the claims processing application? So unless you log it and unless you know the tokens which are going in the consumption, so which is why we are logging the token count, the token consumed per application.
Thank you, Priyanka. I got it. Basically, it's a charging point to we are counting the tokens.
Exactly. Yes, that's right.
So, Priyanka, great presentation. I think it's a very good framework that you guys have built. Question for you: how easy or hard is it to extend the code base to support AWS or GCP?
So just principally the architecture you can reuse, right? But components in the Terraform you will need to swap out. So as I said, it's a bicep or a Terraform, and you just need to swap out the components with your AWS or GCP ecosystem. So it's, I mean, just terminology differences or whichever format the other clouds accept
Components,
your deployments.
right? Not just the components, right? The code also might need to change to an extent. Like if you have, instead of Azure function, you might have an AWS Lambda function and how that plugs in.
Exactly. But again, see, Azure function is again a component of your infrastructure,
Sure, yeah,
a resource which you're provisioning, right, inside of your
right,
resource group. Now, inside you might right now I have used C# as a language, which might not be supported in AWS Lambda. So you might need to go agnostic with Python or something. But yeah, I mean, so
right.
principally, architecture North Star guidance you can retain, and then the Terraform you might have to rewrite for your cloud.
Yeah, thank you.
Amazing. Any other questions?
So Priyanka, maybe I don't follow this completely, but when you show that load balancing across the different models, where it says you give the weightage and then you can swap over, um, won't that impact what the response is if we are going across models? Like, so if we go to a, 4.0 versus,
100%. But see, that is the thing, right? Like, for example, I'm here you are seeing different flavors of models, which is like a bit dated, bit archaic. No, nobody uses 3.5 right now. But
right.
even if it is 4.0 or 4.0 mini, which is not that much divergent in performance. So a 4.0 versus a 4.0 mini versus a 4.0 PTU versus a mini PTU, at least these variants we will have. So we will keep the same flavor of same type of models, but maybe whether it is reserved compute or whether it is pay as you go, that might differ, right? And so you will just see latency in the response time, not in the quality.
Okay. And my thought was like, between like say a 4.0 and a 3.5, and I know that is being sort of pulled off, but wouldn't there be a difference in the response, the quality of response?
Yeah,
Wouldn't that?
that's what I'm saying, right? So
Yeah.
here, if you see, all these are same flavors of models. So it's
Okay.
3.5, 3.5, 3.5, 3.5, 3.5.
Okay, got
Same
it.
here, 3.5.
So it will be across the
In our
same.
production, yeah. So in our production environment also, we will have like the same flavor of models. Just
Mhm.
that, as I said, right, it could be provisioned throughput, which is available because the models are not available locally, or it could be a pay-as-you-go instance of that same model. So you might see delays in your response time, but not in quality. So it's not
Okay.
like, oh, if 4 is not available, I'm going to route you to a 5.3N. No, definitely not, because my application requires only that level of, accuracy. So yes.
Okay. All right. Thank you.
So
Any other
Priyanka,
questions?
No.
the
Sorry.
governance and controls that you have in place, right? Do you have the
Yeah.
flexibility to set it up at, you can put it at a department level, at a project level, individual level, maybe, at a customer level. So do you have different flexibility to set up those kind of governance at this point?
Yes. So look, the governance is again, set up using your Azure policies. Okay. So
Mm-hmm.
that policies you can apply to, again, as I said, like if your data is extremely sensitive and you can't, use your data without masking at all. Okay. So then, yes, I mean, those applications will be subject to different forms of governance. Or before the APM is hit, I might do some kind of data sanity checks to see if PII data is not coming in through the request itself. So yeah, again, it will be a bit of, that's why we have that onboarding process, right? Like how quickly you can onboard. You just need access to APIM, or you need some, exceptions again to be able to operate with your data. You need private endpoints, private links. So all of that would be a part of your onboarding. And then basis that we will be able to give you access.
And the rate limit or the TPM and all that can be set at
It is set at the policy. I showed you the APIM, right? APIM
yeah.
has all of these policies out of the box to be able to set the rate limit, to be able to even, for some flavors of models, it also allows you to calculate the token consumption at the policy level itself. So directly, if you go back here, yeah, if you go back and I go, if I show you the APIM, there, as a tag itself, you can set the OpenAI rate limits in the APIM. Like how we set the authentication, same way we can set the or the logging, same way we can set the rate limit. So you say OpenAI API 3.5 rate limit is 1,000. So that you can do it at the policy level here itself, in the APIM itself here. In the policies, yeah, you can have, like authentication is set, you can have a rate limiting policy here itself.
Okay.
Amazing. Right.
Cool.
I have a couple of questions.
Yes.
So from what I got out of it, Priyanka, is it seems like APM is like this superhero god, right? That can like pretty much do everything. So it seems it's amazing, but I would love to hear, are there any things or specifically some examples where it's something that it's not good at, especially when you're trying to apply it to some fast-moving AI workflows or data-centric pipelines? And are there any kind of trade-offs between speed and control?
And the only thing is, and see, APIM is enterprise scale gateway. Okay. So it's like your API gateway. So it can handle tremendous amount of workloads, and it comes in different flavors. So there is premium, there is standard. So tiers are different, right? So if you talk of the APIM limitations, it's only for pricing. And again, you can also have a lot of API gateway instances too, right? So if one APIM is down, you are rerouting or load balancing it to one another instance somewhere. So all that high availability configuration you can do in configuring your API gateway instances. But cost is a factor, right? Like the more robust you want to make your applications, the more you need to invest in provisioning those many resources. So yes, so right now the customer which we are using this deployment for is a international healthcare customer. So their budget is quite large. They have deep pockets. So no issue for them to even rack up a consumption of 100 USD per department per month, right? But then all your customers might not have these kind of pockets. So in that case, you might need to investigate some other cheaper instances of gateway, right? And then there will limitations in what it can do, because this is a native Azure component. It can do a lot of things, but if you swap it out with a third-party API gateway, maybe it cannot, handle a lot of these elastic things. Also, one of the limitations of the APIM right now is it is able to support Azure OpenAI APIs. If I swap it out with a llama or a Hugging Face, then the amount of control I'm having over what I can log is limited. So maybe prompt tokens I'll be able to log, but as I said, right, like I can for Azure service I'm able to log page count and character count and write down to the level of which operation I'm invoking. That is a limitation right now with not supporting any other flavors of models apart from Azure OpenAI 11s.
Okay, now that's very helpful. And just one more thing. And of course, you know how much we love to talk about responsible AI.
Yes.
Are there any things that kind of come to mind where you can say that, yes, APIM is also very good, or it can be leveraged to enforce responsible AI usage, right? Of course, I know you talked about, user consent, but also like around regulatory compliance.
So that will come in at your AI workload levels. APIM is just a gateway for invoking your APIs, right? So now what kind of prompt you are sending? Okay, does it have, is the response fair? And, are there hallucinations? Those will be controls of AI which you would be placing over your LLMs themselves. So APIM is just going to be a gateway to access the APIs, and your ethical AI controls will be at the foundry level or the,
Model level.
the
Yeah.
model level.
Yep.
Yes.
All right. Sounds good. Thank you.
Any other questions?
In
Anyone?
the chat. Oh, that was just Rupa. Anything else? Final call. All right. Looks like nothing. Well, Priyanka, thank you so much. This was actually very rich, and much more than I had anticipated. I'm definitely like blown away with what you have shared with us. So, thank you so much for taking the time to, come early. It's, several hours ahead. So we really appreciate, and thank you to our audience for coming and, making time on a Wednesday evening. It's late, so thank you very much. Really appreciate it. And yes, stay tuned for our next speakers that are going to be coming up very soon. We have some exciting speakers, so follow me and Padmini. And yeah, looking forward to seeing you guys soon. Thank you, everybody.
Thank
Thank
you.
you.
Thank
Have a
you.
good
Have a good
evening.
evening.
Thanks.
See you. Bye.
Bye.
Thanks,
Thank
Priyanka.
you.
Bye.
Thank you. Bye.